Alright, welcome back, boys and girls. What we are going to do now is the third part of this problem, which we haven't really talked about a whole lot. So let's just take a look at the problem real quickly, and I'll kind of describe what it's actually trying to say. Alright, so it says find the particular solution, y is equal to f of x, for the given differential equation with the initial condition f of 2 is equal to 3. Again, that's just a point where the x is 2 and the y is 3. Okay, so what they are asking us to do is they are asking us to take this derivative and take it backwards into an actual equation. Now, this is something that we haven't really done before because this derivative has both an x and a y in this same equation at the same time. So what we're going to have to do is we're going to have to do a thing called a separation of variables. So what we're going to do is think of this as a true blue fraction, dy divided by dx, y squared over x minus 1. What we're going to do is we're going to get this, all the x's over here and all the y's over here, and you do it just by sheer math. So in essence, what we're going to do right now is in essence kind of cross multiply. Alright, so I need to get this y over here, so this is going to be a division of y, so this would end up with a y to the negative 2 dy. I'm not moving it. Alright, that leaves me with an x minus 1 as a denominator, and this dx is going to multiply over here. Alright, so that's the separation of variables right here. So what I've accomplished is all the y's on this side, all the x's on this side. Now that this is set up this way, what we want to do is get this back down to a straight up, just a regular y, no d anythings. Alright, so to do that, what we're going to have to do is we integrate, after we have this separation, we integrate both of these sides. Alright, so we add 1, so this is y negative 1, flip it down, negative 1. Okay, you could do u substitution on this side, etc., etc. You can pretty much take my word for it, though. It's going to be ln x minus 1. And then, okay, so both of these sides should have a plus c on there. But because you did this all at once, what we do is we just add one generic plus c at the very end, and this c will encompass the entire problem. All right, now, the c is now our problem. We need to get rid of this c somehow. That's where the initial condition comes into play. All right, so they gave us the initial condition. They gave us there's a point 2, 3 in the actual equation. So what we're going to do is we're going to plug that 2, 3 in, and then we're going to solve for our unknown c. Okay, so this is negative 1 over y, which is 3 to the 1, is equal to the ln of x, which is 2, minus 1, plus c. Alright, so that I injected that 2, 3 into the equation. Alright, math time. Alright, so ln, 2 minus 1 is 1. Okay, plus c, negative 1/3. Okay, the ln of 1, if you kind of remember, however you remember this, is at 1, the coordinate is 0. So that's very fortuitous for us because ln of 1 is 0. So this is in essence saying c, that's 0, is equal to negative 1/3. Hooray! c is equal to 1/3. Now what we do is we take this c and we go and we plug it back into here, and then we're going to solve for this unknown y. Alright, so cleaning this up just a little bit, this is negative 1 over y to the negative 1, is equal to ln of x minus 1 plus c, and that's minus 1/3. Alright, so what I do to solve this one is, this is kind of quick and dirty. I do my law of switcho-changeo, and I'm just going to move the y out and the ln down, etc., all that stuff. So this will leave us with, I'll write it on this side, so y, ln goes down. So this is ln of x minus 1 minus 1/3, all as a denominator of -1. And that is a condition of the separation of variables. So this was the original equation. Again, you can change the way this looks. Like if you take this negative, you can flip the order of the denominator by, in essence, GCFing out a negative. But this is a problem that they're going to ask you to do. So again, separation of variables is you get all the y's on one side, so that includes the dy. So that stays and you divide over. And then that leaves us x minus 1, so you leave all the x's, and then you multiply out. So I just multiplied that dx, and that's the separation of variables. Integrate. Okay, plug in your initial condition. So math, math, math. Solve for that c. Okay, replug. And then solve again for y, and this is the actual answer that they're looking for right here. Nothing. So don't forget the plus c, separation of variables. That's the whole concept right there. I don't know if I'm getting a good shot. All right, kids. I will talk to you next time.